numbers. What if you have 3 and a fourth, and you're subtracting from that 2 and 3/4? All right. Now, if I tried to do this the way that I showed you that you could add these things together. Now, if this was an addition, I would say 3 plus 2 is 5, and you add these guys together, you get 4/4, which is another one, and so you would get altogether 6 when you add these together, using the first way that we talked about. Now, if you try to apply this to subtraction, 3 minus 2 is 1, right? And then you try to subtract the fractions. You have 1/4 minus 3/4. All right, now you have an immediate problem here. Because you do have a common denominator, that's cool, but then 1 minus 3, how do you handle 1 minus 3? All right, that's not something that's very easy to handle here. So you run into problems here. Now clearly 3 and a fourth is bigger than 2 and a third, so you certainly can subtract them. But because sometimes the top fraction is going to have a smaller numerator than the denominator, you're not sure what to do sometimes when you end up subtracting these things. I could show you a method to do it this way. I could show you how to handle it, but honestly there's just a much easier way to subtract mixed numbers, and it's something that we've kind of already learned. The second way I told you to deal with mixed numbers is just convert them both to improper fractions and then subtract or add them. In this case, I'm going to tell you that's much, much easier. So don't try to do this. Whenever you're subtracting mixed numbers like that, just don't try to subtract the whole numbers and then subtract the fractions. It just can lead to problems sometimes, depending on what your exact fractions really are. And so instead of showing you how to deal with this and confusing you, I'm going to show you the much, 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 much simpler way to handle it. So let's do this problem again. Let's say we have 3 and a fourth, and we're subtracting 2 and 3/4. All right, now what we're going to do is convert both of these fractions to improper fractions. That was method number 2 when we were learning how to add these things. 3 times 4 is 12, plus 1 gives me 13. And we always write it over 4 over the same denominator. This one, 4 times 2 is 8, plus 3 is going to be 11. So you have 11/4. All right, and now you simply subtract them. Notice now we have already a common denominator in this case, which is 4. So we'll keep the 4 in the answer. All right, and then we'll have 13 minus 11, which will give us 2/4. So we could circle that, but then we realize, hey, we can simplify this. We can divide the top by 2 and the bottom by 2. What we will get, 2 divided by 2 is 1. 4 divided by 2 is 2. The answer is 1/2. That is the answer. Now, notice how simple that was and how bulletproof that was. We just changed these to improper fractions, right? Then subtract them, and then simplify, and you'll never run into any confusion. There is a way I could show you to handle doing it this way. I could take time and show you that. But to be honest with you, it's not worth it because this is much easier when you're subtracting mixed numbers. So I'd like for you to get in the habit of when you subtract mixed numbers, just do it this way. Just convert them to improper fractions, subtract them, and then simplify them. Let's do another problem, and I'll show you how easy it is to implement this for all of the problems that we'll do here. What if we have 3 and a half, and we're subtracting from it 1 and 1/4? All right? So rather than try to figure out how to do it the other way, we'll just change this to an improper fraction. 2 times 3 is 6, plus 1 is 7, and we always write it over 2. This one is 4 times 1 is 4, plus 1 is 5, and we always write it over 4. Now we have 2 improper fractions, but unfortunately we don't have a common denominator now. So now all of the rules of fraction, subtraction, addition, they all apply. You still have to find a common denominator because we would like to subtract these fractions from one another. The easiest way that I can see to do that is just to transform this fraction, because 7/2, if I multiply the top and the bottom by 2, what I will get is 14/4. This one I don't have to manipulate at all. I'll just leave it as 5/4, right? And now I have a common denominator. So now I can subtract these fractions. So we're just using the skills that we already have from before. So on the denominator, we will keep the 4 because it's common. 14 minus 5 is going to give me 9. And I will have 9/4. So we try to see, can we simplify this answer? Well, 9/4 is already simplified from the point of view of we can't divide top and bottom by anything to make it simpler. But we also notice that this is an improper fraction. So when you have improper fraction, you almost always want to convert it back to mixed, especially since your problem was given to you as mixed number subtraction. So if we want to convert this back to mixed, how do we do it? We just divide 4 into 9. How many times will 4 go into 9? It'll go 2 times because 4 times 2 is 8. And 9 minus 8 is 1, so the remainder is 1, and I write it over 4. This is just converting this back to mixed number, and the answer is 2 1/4. That's the final answer. Much, much simpler. I know there's a few steps involved, but every step along the way here you already know how to do. We just need to give you the practice to put it all together. First step is convert these to improper. Okay, we've done that. Next step, find the common denominator. Okay, we've done that. Next step, subtract the fractions. We've done that. Final step, simplify and convert back into a mixed number. We've done that. So all of those little steps we've learned along the way, and now you understand why everything in math builds on one another, and that's why we do so much practice. So let's go ahead and do another problem and get some additional practice right now. Let's say we have 4 2/3, and we're subtracting from that 2 1/6. Right, we want to subtract that. So we subtract mixed numbers. First thing you should say is I'm going to convert this into an improper fraction. 4 times 3 is 12, plus 2 is 14, and I write it over 3. This one, 6 times 2 is 12, plus 1 is 13 over 6. So I have 14 over 3 and 13 over 6, and I do not have a common denominator. So now I need to use my other skill to change this into some situation where I have a common denominator. And the easiest way I see to do that is I take this top fraction, multiply top and bottom by 2, because then 14 times 2, don't forget 14 times 2, if you do that, is 28, right? 3 times 2 is 6, all right? This one I don't have to change at all, 13 over 6. So I chose to just change the top fraction and make it over 6. And now I have a common denominator of 6, so I can subtract that. 6 goes on the bottom, and then you have to do 28 minus 13. If you do 28 minus 13, you can see the 8 minus the 3 is going to give you a 5, 2 minus 1 is going to give you 1, so you get 15 over 6. And then you look and say, can I simplify this? And so let's go ahead and try to change it to a mixed fraction, right? How many times can 6 go into 15? Well, 6 times 2 is 12. 6 times 3 is 18. That's too much. So it can only go 2 times. 6 times 2 is 12. The difference between 15 and 12 is 3, and I always write it over 6. So I could circle that, but then I noticed that the fractional part here, the 3 over 6, can be simplified. So the final thing I do is I look at 2 3/6, and I try to simplify that further, and I see that I can divide this by 3, and I can divide this by 3. So the final answer for this problem is 2, and 3 divided by 3 is 1, and 6 divided by 3 is 2, 2 1/2. So in truth, once you did the subtraction here, this is the answer, but this is the mixed number form of it, and this is the fully simplified mixed number form of it, 2 1/2. I highly encourage you to work these problems yourself because you're going to gain a lot of experience in how to do all of these skills in one problem, converting back and forth between mixed and improper, simplifying and things like that. But the good news is I mean, really, you don't have to learn a million different things. You're really doing the same thing all the time. We have 5 5/6, and we'd like to subtract from it 1 2/3. All right, so when you see a subtraction of mixed numbers, I want you to think, I'm going to convert these to improper. So 6 times 5 is 30, plus 5 is 35, and we write it over the same denominator, 6. 1 times 3 is 3, plus 2 is 5, and we always write it over the same denominator. In this case, the denominator here is 3, so we write it over there. So we have 35/6 minus 5/3. We can't do that as written because we have unlike denominators. So we look for a way to change this. I know that 3 times 2 is 6, so I'm going to write this as 5/3. And I'm going to multiply this times 2, and what I'm going to get is 10 over 6. This guy, I don't have to change at all, 35 over 6, and I have now a common denominator. I'll write a subtraction symbol to remind me that I'm subtracting these guys. And then over here, since I have a common denominator, I'll keep it as a 6, and then 35 minus 10 is 25. All right, now look at that, and I say that looks pretty good, but it's an improper fraction. Let me try to simplify that. How many times can 6 go into 25? Well, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24. 6 times 4 is 24. So 6 times 4 is 24, so I'll put a 4 there. The difference between 24 and 25 is a remainder of 1, and I just write it over 6. That's the final answer, 4 1/6. This is the final answer in terms of improper. This is the final answer in terms of a mixed number or a mixed fraction. They both represent the same thing. We choose to go back to mixed number because our problem is given to us in terms of mixed numbers. All right? All right, let's do one more. This will be the last one. We have 1 7/8 minus simply 2/3. So we have a mixed number, but we're subtracting just sort of like a regular fraction from it. So you might be confused. What do I do? Well, it's really no different. We still need to convert this to mixed number, right? 8 times 1 is 8. 8 plus 7 is 15. And then I have to keep it over the same denominator, which is an 8. This fraction is already as a fraction, so I'm just going to keep it as 2/3. Now I need to subtract these two fractions. Now, this is an 8 and this is a 3. Clearly they're not the same, so I need to change the fractions. I can't just change this one to make the bottom 8, and I can't change this bottom to make it a 3. So I need to change both, so I'm looking for a common denominator. All right, I'm going to jump on 24 as a common denominator because I know that 8 times 3 is 24, and it's the first thing that comes to mind for me, right? So for this one, if I'm going to change this one, 15 over 8 into 24, I'll need to multiply top and bottom by 3. And when I do that, 15 times 3, when you do 15 times 3, you'll get 45. And 8 times 3, you'll get 24. And then here, when I do this one, when I transform this one, I'll have 2/3. In order to transform that denominator to 24, I'll multiply it by 8 and by 8. 2 times 8 is 16, and the bottom is again 24. And I'm subtracting, so I'll draw my line. So now I look and I say, my life is a lot better because I have 45 24ths minus 16 over 24ths. So I'm going to retain the same common denominator of 24. And then 45 minus 16, you may not know how to do that in your head, so we'll just go off to the side and say 45 minus 16. Can't do this, so we'll carry that guy, scratch this out, and make him a 3. 15 minus 6 is going to give me a 9. 3 minus 1 is going to give me a 2. So the answer I get is 29, so that goes right into this spot, 29. So I look and say, can I just circle this? And I say, well, it's improper, so how many times can 24 go into 29? Well, only one time. The difference between 24 and 29 is 5 over 24. Keep the same denominator, circle the answer. 1 5/24.